Okay, let's dive in. Is your cloud storage truly the powerhouse you envisioned for your business? Or has it maybe become more of a digital swamp, just holding data that isn't really working for you?
Yeah, it's a common trap.
We tend to think that just, dumping our information into platforms like S3 or maybe ADLS or GCS, that just ticks the data management box.
Right. But what often gets overlooked, I think, is that the true value of that data is kind of locked away until it can efficiently fuel your analytics engines.
Mm.
We're talking platforms like Snowflake, BigQuery, Databricks, Snaps.
Mhm.
Think of it like having a library full of incredible books, but no way to actually read them easily.
Mm.
Disconnected storage and analytics create this bottleneck that really stifles insights.
Right. So in this deep dive, we're tackling that mission-critical task,
Oh,
seamlessly connecting your cloud storage to your analytics. I mean, the modern data landscape offers fantastic flexibility with this decoupled architecture, right?
right.
Choosing the best tool for each job.
Absolutely.
Yeah.
But that freedom, it also means we need to be smart about building robust bridges, let's call them, between these vital systems.
Bridges, okay. So how do we build these bridges? What are the main ways?
Well, when we talk about these bridges, there are really two primary approaches for your analytics platform to get at that data sitting in your cloud storage.
Okay.
The first one is direct querying. You might also hear this called external table access or query federation sometimes.
Ah,
Platforms like BigQuery, Snowflake, Redshift Spectrum, Databricks, they all offer this capability.
okay. So instead of the, let's say, traditional method of physically moving all the data into the analytics platform first,
Exactly.
direct querying lets you essentially point your analytics tool at the data in cloud storage and run SQL queries right there. Is that it?
Precisely, yeah. It gives you remarkable agility because you can analyze data without that upfront effort and cost of ingestion.
But there's a catch, I assume, for performance.
Well, yeah, to really get the most out of it, performance-wise, a few key things are crucial. The data should ideally be in columnar formats.
Hmm.
Think Parquet or ORC.
Right.
These formats are, specifically designed for analytical workloads. They let the system read only the columns it actually needs for a query.
Makes sense.
Compression is also key. It minimizes the amount of data being scanned and transferred, which directly hits your speed and, importantly, your costs.
Okay.
And finally, proper partitioning. So strategically organizing your data in storage, maybe by date or by region, based on how you usually query it, that can lead to really significant performance gains.
Got it. So columnar format, compression, partitioning, that makes direct querying sound incredibly useful for its flexibility. Now, what's the other main method?
The other primary method would be data loading. This involves actually taking the raw or maybe semi-structured data from your cloud storage and bringing it into the analytics platform's own internal processing engine.
Okay, loading it in.
Yeah. We're talking bulk operations here. Things like running, copy-wide commands or setting up regular batch jobs to physically move the data across.
And when would you choose this approach over the direct querying we just talked about?
Data loading often proves to be the better strategy for, let's say, high-performance analytical workloads, where you need the absolute fastest query response times possible.
Right, maximum speed.
Exactly. And it's also preferred when you need to perform significant data transformations as part of the process before the data is really ready for analysis.
And what kind of tools help with that loading process?
Oh, common tools you might see orchestrating these kinds of data loading pipelines include things like Apache Airflow, Azure Data Factory, or dbt is very popular now too for the transformation part, often linked with loading.
Okay. And just briefly, how does streaming data fit into this? That feels a bit different.
It is, yes, slightly different beast. Streaming integration deals with a near real-time flow of data, often managed through services like Kafka or AWS Kinesis, Google Cloud PubSub. And this data, it can either be temporarily landed or staged in cloud storage for subsequent batch processing, kind of linking back to our loading method, or in some cases, it can be directly ingested into analytics platforms that have native support for streaming.
Okay. So whether we're talking direct querying, bulk loading, or these streaming feeds, are there some sort of fundamental best practices that cut across all of them?
Absolutely. Yeah, definitely. Regardless of the specific integration pattern you choose, the format of your data matters immensely. Sticking to those columnar formats like Parquet or ORC is almost always a good idea for analytical use cases.
Right, format first.
Then proper partitioning, like we discussed for direct querying, that also plays a vital role in optimizing performance pretty much across the board. And of course, you need robust access controls. That's paramount for security.
Security, always key.
always. And finally, a really, really key consideration, often overlooked, is the proximity of your compute resources, your analytics engine to your storage. Ideally, you want them co-located in the same cloud region to minimize latency and keep those data transfer costs down.
Ah, co-location. Good point. Can you give us a tangible example? Like, how does getting this right actually make a difference in practice?
Sure. So imagine you're trying to analyze, say, website traffic data,
Hmm.
and it's stored as just raw CSV files in S3.
Okay.
And you try to query it using a service like AWS Athena, because CSV isn't optimized for analytical queries, right? It reads row by row,
Yeah.
and Athena might have to scan the entire file or many files. These queries can be quite slow and, frankly, surprisingly expensive depending on the data size.
Right. Scanning everything.
Exactly. Now, contrast that. If you take those same CSV files, convert them to compressed Parquet,
Mm.
maybe partition them by date,
Mm.
and then run the same queries in Athena, you'll likely see a dramatic improvement in speed, like orders of magnitude faster, and a significant reduction in cost because Athena can be much smarter, much more selective about the data it actually needs to read and process.
That's a great illustration. Okay, what about on the data loading side?
Okay, think about trying to load a massive data set, maybe hundreds of gigabytes, terabytes even, into, say, Snowflake. And it's coming from just a disorganized collection of small flat files in your cloud storage.
Yeah, that sounds messy.
It can be. That process could take a really considerable amount of time, and it could consume a lot of expensive compute resources in Snowflake.
However,
If you first stage those files efficiently in cloud storage, maybe combine small files into larger ones, leverage Snowflake's internal micro-partitioning by structuring the load correctly, and then load the data in parallel, you can achieve really substantial time and cost savings. Huge difference.
so it sounds like ultimately getting this data integration piece right isn't just some technical detail for the engineers to fuss over. It really impacts the business, doesn't it?
Exactly. It absolutely does. Efficient integration translates directly to faster analytics, which means faster insights. It means stronger data security because you have clear pathways and controls. And it builds a more scalable data ecosystem overall.
Scalable enough for what kind of things?
Well, everything from your standard business intelligence dashboards that need quick refreshes, right up to feeding the complex data pipelines for advanced AI and machine learning initiatives. This agility allows for quicker, more informed decision-making, and that gives businesses a crucial competitive edge.
Okay, so the big message here, the main takeaway, is that just having your data in the cloud, just storing it, isn't the end goal at all. You need to be really strategic about how that data moves, how it flows into your analytics environment to unlock its actual potential.
Precisely. It's all about the flow. And if you're keen to dive deeper into the specifics here, integrating platforms like S3, ADLS, or GCS with your particular analytics setup, we highly recommend checking out the full blog post this discussion is based on. It's called Integrating Cloud Storage for Efficient Analytics. Really packed with practical advice and best practices.
Good recommendation. And for those of you maybe in strategy roles or looking to really enhance your own data integration capabilities or your teams, our colleagues over at Curate Partners are doing some really cutting edge work. They help organizations build smarter data systems. And, they're always on the lookout for talented people to join their teams too. Worth checking out.
Definitely. So as you continue to build out and refine your data infrastructure, just remember that crucial role of data flow.
Until our next deep dive, focus on building those effective data bridges. Remember, it's not just about where the data lives, but how actively and efficiently it's working for you.